Another type of figure that we're going to work with today is a parallelogram. And the thing about parallelograms is that trapezoid says that you have to have at least one pair of parallel sides. A parallelogram says that you have to have both pairs of opposite sides parallel. So that means that this and this side are parallel, and then this side and this side are parallel. Both of them need to be parallel. So if we look at a couple of true and false here, is a parallelogram a trapezoid? Well, again, a parallelogram has two pairs of parallel sides. A trapezoid says that you have to have at least one pair of parallel sides. So yes, a parallelogram is a trapezoid. But the other direction doesn't work. Again, parallelogram says that both sides have to be parallel, and a trapezoid says that we only have to have one side parallel. So we're false here. If we take a look at our picture, we're going to draw this in here. We're going to graph those points. And then we're going to determine if ABCD is a parallelogram by showing that the opposite sides are parallel. And we've already talked about today the fact that when we're dealing with parallel lines, so to speak, we have to have the slopes equal. So we'll draw our picture. -1, 4. There's A. -5, 1. Here's B. -3, -2. Here's C. And 1, 1. Here's D. And there's our picture. And again, what we need to show is we need to show that we've got two sets of parallel sides. We want to show that AB is parallel to CD. And when we show that, again, what we're doing is we're going to find the slope of AB. We're going to find the slope of CD. And again, you might just want to color code it to keep track of things. But if we draw our rise over run, the definition of slope, we've got rise 3. For the slope of AB, I should write this down. Slope of AB, we rise 3. We're going to run 1, 2, 3, 4 to the right. So rising 3 means positive, to the right means positive, so 3/4. But we want to compare that to the slope of CD. So again, we're going to draw our triangle. And we've got 1, 2, 3 down. And we've got 1, 2, 3, 4 to the left. And does 3/4 equal -3 over -4? Yes, because two negatives make a positive. So what we've shown so far is that slope of AB and slope of CD are the same. But in a parallelogram, we have to have both sets. We have to have two sets of parallel sides. So we'll look over here now at the other two, and we're going to figure out BC parallel to AD. And we're going to draw our triangles again. Slope, rise over run. BC, well, in this case, what we've got is we went down 3 and to the right 2. So our slope of BC, down 3 and to the right 2. down means negative, but we went to the right, it's 2. If we look at the slope of AD, we'll draw a triangle, and we'll do the rise over the run. And we went up 1, 2, 3, and to the left 2, up 3, it's positive. To the left is going to be negative. And even though the negative is on the top on the first side, and it's on the bottom on the second side, there's only one negative in both those fractions, which ultimately means that they're negative 3/2 is the slope. And once we've determined that, then we can explain here, to answer a question, it says determine if ABCD is a parallelogram. And we can say, yes, it's a parallelogram because opposite sides are parallel. They have the same slope. One final type of quadrilateral that we're going to talk about today is a quadrilateral that's called a kite. And this one's a little bit different from the previous two because it's a quadrilateral, so it still has 4 sides, but it has 2 pairs of congruent consecutive sides. So in this case, what we see in here is we've got FG and FJ. They both have 2 tick marks in them. Side by side sides, and that doesn't, right next to is maybe better words to say. FG and J are congruent. And then the other 2, GH and HJ, are also congruent. It looks like your traditional kite if you go outside when it's a windy day and fly a kite. There's a couple more pieces of information that we need to know, and here comes the diagonals again. And what we know in a kite is that the diagonals are perpendicular. Try to scoot that in there a little bit. Diagonals are perpendicular. They hit at 90 degrees. And we see that picture in there. Or notice, FH, there's one diagonal, is perpendicular to GJ. It would be like the wooden sticks, and I don't know if they still make them, it's probably plastic now in a kite. But it's the skeleton backbone of a kite. Those are the diagonals, and they're perpendicular. The other information that we need to know about kites is that there's one pair of opposite angles. In this case, what we've got is angle G is congruent to angle J. And now what we can do is, well, we've got a true and false question to answer, and then we'll finish. A kite is a trapezoid. Well, trapezoid has to have at least one pair of parallel sides, and we don't have any parallel sides. So that's false. And again, a kite is a parallelogram. Well, a kite doesn't have any parallel sides. So it's not a trapezoid, it's not a parallelogram, it's a quadrilateral. It's a 4-sided figure. But as we finish here on this last example, quadrilateral OWEN has vertices at O, well, at all those points right there. Determine if OWEN is a kite by showing that the diagonals are perpendicular. Show all work and explain your reasoning. So first of all, let's plot the points here. And my points are a little bit out of order, but we can still deal with this problem. We can still get it done. 3, 4 is O. -2, 4 is W. E is 3, -1. And N is -5, -4. So here is our possible kite. So determine if OWEN, and I want to go back and label this here, finish labeling it. Here's E and here's N. Determine if OWEN is a kite by showing that the diagonals are perpendicular. So what we're looking at here is we want to show that NO, there's one diagonal, is perpendicular to WE. So it's kind of like the bones of a kite is what we're looking at here. But let's figure out what the slope of NO is. And then we're going to count here. So when we draw this in, remember it's going to be rise over run. And when we look at this one, we've got 1, 2, 3, 4, 5, 6, 7, 8. 8 down. And then we're going to go 8 left. 1, 2, 3, 4, 5, 6, 7, 8. 8 left. Remember, we need to simplify these. So -8 divided by -8 is +1. But we also need to figure out the slope of WE. So our slope of WE, again, we're going to draw a triangle. And let's see, here's E and W. So we're going to go 1, 2, 3, 4, 5 up. And 1, 2, 3, 4, 5 left. Left is a negative. And when we simplify this, that equals -1. So we've got a slope of 1, we've got a slope of -1, and we want to show that diagonals are perpendicular. Well, the thing that we need to remember is that when something is perpendicular, we have to have slopes. Let me write it. Slopes must be opposite reciprocals. For them to be perpendicular. So if we compare this, what we have is we have 1 over 1, and we have -1 over 1. And what happens is we can flip one of these, so it becomes 1 over 1, but not, there's the flip, that's the reciprocal part, and then we would have to change the sign. So these two are opposite reciprocals, and then we can finish by adding, if we leave that, slopes must be opposite reciprocals, so the diagonals are perpendicular. And we can't just write. We have to show our work to support our statement there.